in the notes just kind of summarizes the points of concurrency. The point of concurrency of the perpendicular bisectors of a triangle is the circumcenter, the center of a circle that could be drawn around the triangle, and the edge of the circle would touch all of the vertices of the triangle. The point of concurrency of the altitudes of a triangle is called the orthocenter. The point of concurrency of the angle bisectors of a triangle is called the incenter. That's the center of a circle that can be drawn inside of the triangle, where each edge of the circle would touch the edge of the triangle. The point of concurrency of the medians of a triangle is called the centroid. It's the center of gravity, and it splits that point of concurrency splits the medians into a ratio where one is 1/3 of the whole length and one is 2/3 of the whole length. It just splits them proportionally like that. Which of these points can be located outside the triangle? The circumcenter and the orthocenter can be found sometimes outside of the triangle. And which of these points of concurrency are always located inside of the triangle will be the incenter and the centroid. Here we begin talking about the triangle inequality theorem. The hinge theorem, I believe, is going to be in a different video, so pretty much this video is just going to focus on the triangle inequality. If one side of a triangle is longer than another side, then the angle opposite the longer side is greater than the angle opposite the shorter side. So right here, if AB is longer than BC, then the angle across from AB, which is C, is larger than the angle across from BC, which is A. So, C is larger because the side across from it is larger. If one angle of a triangle is larger than another, then the side opposite the larger angle is greater than the side opposite the smaller angle. So if A is greater than C, BC will be longer than AB. So here we have a question, and it says to list the sides in order from shortest to longest. And so I like to start by listing the angles in order. So the smallest angle is angle P. The next one is angle R. And the largest is angle Q. So these are the angles from smallest to largest. They're not going to ask me this because they gave me the angles, and that's just basically putting three numbers in order. They're asking me about the sides. So I need to use these angle measures to figure out the sides across from them and put those in order. The side across from angle P, and if you want to cover angle P, you can see that the only letters that you can see now are Q and R. So the side QR is across from P, and QR will be the shortest because it's across from the smallest angle. So I'm listing the length QR less than angle R. Let's cover angle R and see that PQ are the letters that you can still see. So PQ is the side across from R, and then that will be smaller than, since Q is the longest, the side across from Q, or angle Q is the largest, the longest side will be across from it, so the longest side will be PR. So from P to R is the longest measure there. So listing our sides in order from shortest to longest, here they are. In order, shortest to longest. Right here it says a boat makes a trip whose path has sides of 1.5 miles, 2 miles, and 2.5 miles long with angles of 90 degrees, approximately 53 degrees, and approximately 37 degrees. Sketch and label a picture of the trip route. So I have got a 90-degree angle, so I know that I have a right triangle. So I'm just going to draw a right triangle. There we go. And this is not going to be drawn to scale. So I know that I have a 90-degree angle, and I have a 37-degree angle, and a 53-degree angle. And those kind of look the same, so we're just labeling them and saying it's not drawn to scale. So the shortest side measure should be across from the smallest angle. So since 37 is the smallest, across from it is the 1.5 miles. Then the 90 degree is the largest, so across from it is the longest side, which is the 2.5 miles. And then the medium angle is the 53, and the medium side is 2 miles, so across from the 50 is the 2 miles. And so here we've sketched and labeled a picture of the trip route. This is the triangle inequality theorem, and it says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if we add two sides, they have to add two more than the third one. And so here's just a list of all the combinations you could have: AB and BC greater than AC, AC and AB greater than BC, BC plus AC needs to be greater than AB. And so here is a question asking about what are the possible lengths of a third side when we're given two measurements. And so the side, we put that in between a low value and a high value. And it has to be, this side, the third side, must be more than the difference between the two. So if you do 23 minus 17, you get 6. And then it has to be less than if you add them together. So adding the 23 and the 17 gives us 40. And these were in meters. So let me add meters on the end there. So here would be all the possible lengths of the third side. You always want to write it as an inequality because, I mean, it could be decimal values, not just whole number values. So it's somewhere between 6 and 40, more than 6 and less than 40.